back to my YouTube channel, Beloved Academy. Thank you very much for watching the video. In today's video, we are going to be treating the concept of linear programming. As you know, linear programming is one of the mathematical programming that is used in making an optimal decision. Now, in today's video, we are going to be treating linear programming. And when we talk about linear programming, there are various methods of solving questions involving linear programming. But in this video, I'm going to be talking about two methods, which are we have the graphical method, the graphical method, and the simplex method, the simplex method. Yeah. We have These are the two methods that I'm going to be talking about in today's video. We have the graphical method and the simplex method. Now, in the graphical, let's assume. Okay, now we are taught to find using graphical method, we are taught to provide solution to this linear programming problem. How do we go about that? It is very, very simple. Just follow me carefully. The first thing to do is to find your coordinates. And how do you find your coordinates? You set each element in this, this is the maximum and this is the constraint to which this is subjected to. So if you want to find the coordinates, you take into consideration the constraint. So this is our constraint. We have three constraints, which is we have constraint 1, constraint 2, and constraint 3. Now, if you want to find the coordinate of this constraint, you have to set each element in the constraint as 0. We have two unknown variable, we have x1 and x2. Now you have to set each element to find the coordinate of x, to find the value of x2, you have to set x1 as to 0. Then after that, you make x2 the subject of the relation, then you get the value of your x2, and that's what I'm going to be doing right now. Now let's continue. We have solution here. For the first constraint, this is the first constraint. Now 4x1 plus 5x2 is less than or equals to 20. Now set x1, let us set x1 to 0. x1, when x1 equals to 0, we have 4 multiplied by 0 plus 5x2 equals to 20. So 4 multiplied by 0 will give us 0. So we are going to be having 0 plus 5x2 equals to 20. So make x2 the subject of the relation. We are going to be having x2 is equals to 20 all over 5. So x2 is equals to 4. So when x1 is 0, we have x2 as. Okay, now we have get x2 for the first constraint. Now let's proceed to get our x1. If you want to get the value of x1 for this inequality, you set x2 to 0. So by doing that, we are going to result into x1. This is 4x1 plus 5 into bracket 0 is less than or equals to 20. So 4x1 is less than or equals to 20. So x1 is less than or equals to 5. So when x1 is 0, the value of x2 is 4. When x2 is 0, the value of x1 is 5. So the first coordinate is 5. This is the first coordinate, the 5 comma 4. So this is the value of x1 and x2. Now let's proceed to get the value of x1 and x2 for the second constraint, which is this. This is the second constraint. So let's proceed. The second, let me put it down. Second constraint. okay, x2 will be less than or equals to 10. So when x1 is 0 in the second constraint, so x2 is 10. So now let's set the value of x2 equals to 0 to get the value of our x1. So that's what I'm going to be doing now. I'm going to be having, so when x2 equals to 0, x1, we have 5x1 plus 2 into bracket 0 is less than or equals to 20. So x1, this will give us 0. So I'm going to be having x1 is less than or equals to 20 divided by 5. So x1 is less than or equals to 4. So the second coordinate is on x1 4, 10. Now the second coordinate is 4, 10. Now let's proceed to get the value of x1 and x2 for the third constraint. Of course, this is the linear inequalities for the third constraint. So let's proceed. We have the third constraint. So the linear equation is 3x1 plus 8x2 is less than or equals to 24. 3x1 plus 8x2 less than or equals to 24. So in order to get the value of x2, set x1 to be 0. So you are going to be resulting into 3 into bracket 0 plus 8x2 is less than or equals to 24. So we're going to be having 0 plus 8x2 is less than or equals to 24. So make x2 the subject of the relation. You are going to be having is less than or equals to 24 all over 8. x2 is less than or equals to 3. So when we set x1 to 0, when x1 is 0, the value of x2 is what? 3. Now let's set x2 to be 0 to get the value of our x1 at origin. So I'm going to be having when when x1 equals to 0, so I'm going to be having the value, when x2 is equals to 0, I'm going to be having 3x 3x1 plus 8 into bracket 0 is less than or equals to what? 24. So 3x1 plus 0 is less than or equals to 24. So 3x1 is equals to what? Is less than or equals to 24. So x1 is less than or equals to, will be less than or equals to, now 3 divided by 24 will give us 8. So when we set x2 to 0 in this linear inequalities, the value of x1 is 8. So the third coordinate is what? 8, 3. So we have the value of x1 and x2 for the first constraint. We have the value of x1 and x2 for the second constraint. Now we have the value of x1 and x2 for the third constraint. The next thing, so now I'm going to write this coordinate in here because I'm going to be cleaning it now. So I'm going to have for the first constraint, which this is the linear equation for this first constraint, I have, what's my point? My point is what? 5, 4. I have 5, 4. Then for the second constraint, which is this, I have what? 4, 10 for on the value of x. Okay, 4, 10. 4, 10. So for the third constraint, the coordinate is 8, 3. 8, 3. So these are when I plug in all these values. Now let's go and construct our graph. That's the next thing to do. After getting the coordinate like this, after getting the value of x1, x2 like this, when you set each of the element there equal to 0. So after getting this, the next thing is to proceed to plot your graph. So all these coordinates here, I want to plot it on this graph. The first thing to note is that make sure that your x1, we plot the graph of x1. Oh, this is not writing. x1 against x2. So you have your x1 here, and this is the value of x2. Now, if you want to plot your graph, the first coordinate is what? 5, 4. So when x2 is 0, that is at this point, when x2 is at this point, the value of x1 is 5. So 5 will be at this side, around this place. So 5 will be around this place. So when x2 is 0, the value of x1 is what? 5. I put this point. Now, when x1 is 0, the value of x2 is what? 4. So, another point we put here. Now, you have to rule a straight line. So, I have to have my line like this. Yeah. So this is the first coordinate on the graph, this place and this place, for the value of x1 and x2. Now let's proceed. We have another value here, which is 4 and 10. When x2 is 0, the value of x1 is 4. So I'm going to trace this. The value of x1 is 4. I have my points, the first point here. So when x1 is 0, of course this is origin 0, 0. When x1 is 0, the value of x2 is 10. So I'll have another point in this place. So I'm going to trace my line. The line will look like this. Okay. Now let's go to the third constraint, the coordinate there. We have 8, 3. When x2 is 0, the value of x1 is 8. So I have something like this. And when x1 is 0, the value of x2 is what? Is 3. So I'm going to be having from this plane. Let me use that red pen again. Red pen. Okay. It will be somewhere here because this from this place to this place too. So it will come somewhere here. So okay. I've already plotted all my coordinates. Now, the next thing to do, I want to pay attention very well. If you look at this graph, there are some intersection in this graph, and that's what I'm going to be locating right now. Because if you look at the constraints, you will realize that the inequality sign is less than or equals to, the inequality sign is less than or equals to, definitely the our value will move towards the origin. Please, do you understand? Because the inequality sign is less than or equals to, if you look at all these constraints, constraint 1, constraint 2, and constraint 3, you will realize that the signs there, the inequality sign there is less than or equals to, definitely on our graph, the portion of our visible solution will be moving towards what? Towards the origin 0, 0. So I'm going to be having from this, I'm going to paint it from this place to this point. So now I want to locate each point. The next thing to do is to locate the point of intersection. You have the point of intersection here. Don't forget, you have already painted all this place. You have painted all this place. This is the value of our solution. Now we have the point of intersection here, which is what? At this point is what? This particular point. We realize that this is point 4, 0. So I'm going to be write it out. First intersection. You have what? For point 4, 0. Now, okay, let's raise first. Let's just put only intersection. Now, if you proceed, you will realize that another one is here. Now, if you trace it downward, you realize that this is 0, this is 2, and this is 4. This is 2. 3 will be somewhere here. So if you trace that, this is might be 3.1, 3.2, 3.3, 3.4, 3 point. This one is close to 3.8. So the first, and when x1 will be 3.8, 3.8, comma. So at this point, 3.8, then you trace it downward again. This will be 1.7, 1.7, 1.7. Because when you measure here from this place to this place is 0, from this place to this place is what? From this place to this place is 1. So around there, this is 1 point, and it is towards 2. It is closer to 2. So it will be around like 1.7, 1.7. So let's proceed. The first intersection is this. The second intersection is this. So let's proceed. This is another intersection here. Because I told you that since the inequality sign between the inequality signs of our constraints is less than or equals to, I told you that the solution will move towards the the coordinates. So that's the reason why I choose this side. That's the reason why I painted this side. So the third intersection is this. So we trace it back to our x1. We trace it back to our x1 graph, which is on the y-axis. So if you trace it, this is 1. This is theory. This is 3. You have 3, comma. Now the third intersection also, you trace it downward. This is 2 points. It's closer to the middle. I don't know. 2.3, 2.3, 2.3. So this is the third coordinate. Now let's proceed to find the fourth intersection. The fourth, of course, the fourth intersection is here. This is the fourth intersection. This is the fourth intersection, and in the fourth intersection, the value of x1 is 0. As you can see, the value of x1 is 0. There is no rise. So the value, we have 0 comma, the value of x1 is 0. Then the value of x2 is 1, 3 rather, because from 0, 1, 2, this will be 3. So the value of x2 is 3. So now I've already gotten my I've gotten the intersection according from this graph. After plotting this coordinate, I got the feasible solution by, because if assuming let's assume that the inequality sign is greater than or less than, it will move further from the origin 0, 0. Are you getting it? So now let's proceed. Since we have already gotten here, the next thing. Okay, now I've gotten, these are the 4 points that I got from the graph that I plotted when I after plotting this. These are the 4 points of intersection that I got. Now the next thing to do is to go back to our objective function, which is 10x1 plus what? 6x2. The next thing you are going to be doing is to substitute all this. Substitute the value of x1 and x2 that you got in this solution. We are going to be substituting it in this objective function. So the maximum is what we are going to be choosing after substituting it. So let's proceed. For 4, 0, I'm going to be putting it here. For 0.4, 0, when x1 is 4 and x2 is 0, I'm going to be having z, the objective function will be equals to 10 into bracket what? 4 plus 6 into bracket 0. So when x1 is equals to 4 and x2 is equals to 0, the value is what? 6 times 0 is what? 0. So 10 times 4 is 40. So the value is 40. Let's proceed with our calculation. So when x1 and x2 is what? 3.8 and 1.7 respectively, what's the value of z? Z is equals to 10 into bracket 3.8 plus 6 into bracket 1.7. 1.7. So if you punch your calculator, you are going to get, okay, if you punch your calculator, you are going to result into 48.2. So let me put naira or any units that they give you. So now when x1 is 3 and x2 is 2.3, so the objective function will become 10 into bracket 3 plus 6 into bracket 2.3. The objective function will become this. So when you punch your calculator, you are going to result into 37.38. 37.38. Okay. When x1 is equals to 0 and x2 is equals to 3, we are going to be having 10 into brackets 0 plus 6 into bracket 3. So 10 times 0 is 0, 6 times 3 is 18. So let's assume that they gave you that the unit is in naira. So that's what you are going to be getting. Now, if you look at this objective function, at what value of x1 and x2 will this consumer, will this entrepreneur be able to maximize his own profit? If you consider this, you realize that the value of z is at its greatest at 48.2. So the solution to this linear programming is this. The solution to the linear programming objective function of this and the constraint of this, the solution is z equals to the maximum solution is that when x1 is what? At when x1 is 3.8, which is this, and 1.7, that is the solution to this objective function, and this that is subjected to this constraint. Now you can also proceed to plug in your origin 0, 0. You can proceed to plug in origin 0, 0. Of course, the value of z will be 0, so there's no need for plugging that. But in some cases, you might want to input that. You can proceed to plug in when x1 is 0 and x2 is 0. So the solution to this objective function is this. So we have come to the end of this linear programming when we are told to solve the solution using graphical method. On my next video, I'm going to be dropping solution of linear programming using simplex method. Thank you very much for watching the video. kindly hit the notification button and click on the subscribe button. If the content in the channel has one way you like the content, kindly hit the notification bell and click on the subscribe button so that you get updates when I drop my new video. Thank you very much.